Okay, I'm jumping ahead to number 16, designing a can. All right, what are the dimensions of the lightest open top, right, circular cylinder can, cylindrical can, that will hold a volume of 1,000 cubic centimeters? It says to compare the result with example 4, but we don't care about example 4. Let's just solve the problem. All right, what are we even trying to optimize here? What does lightest mean? Lightest, what are we going to do with that? All right, well, let's at least start by drawing a picture. Here's a can, a nice can. Okay, this can is open on the top, so I can, put pencils or something in there, put some pencils in there. All right, it's open on the top. Let's think about the dimensions that the can has. It has a radius, it has a height, just thinking about the dimensions. What does lightest mean? If this can is empty, where is the weight coming from? The only place that weight is occurring, whether I make this out of plastic or aluminum or steel, it's the area that's causing the weight of the can. So when I'm lightest means I want the minimum weight, and that means that I'm trying to minimize surface area. So I would say that is absolutely not obvious in this problem, and that's one of the tricky things to figure out. Okay, and then I got to get an equation for that surface area, and how am I going to do that? Well, so if I think about this can, if the can's got sides and it's got a bottom, all right, what about that side? What if I took that side and unwrapped it, right? So I just unwrapped that curvy side and just flattened it out. So the length of the side of this curvy top here is going to be the circumference of the circle, where the circumference of the circle was 2 pi r. So when I unroll it, it's still going to be 2 pi r, and the height of this is going to be h. If I flatten this out completely, it'll be a rectangle whose area will be 2 pi r times h. We'll actually be using that later, that how to get the surface area of a cylinder is 2 pi r h. But then I also have the bottom, which is just a circle, so that's just pi r squared. Okay, so that's getting the equation of what we're trying to maximize. Also not obvious, but by the way, you could just look it up on the internet. What is the equation for the surface area of an open top right cylinder, and you'll find that. All right, step 2, I need an equation relating the variables. Do I have that? The volume is 1,000 cubic centimeters. What can I do with that? The volume is 1,000 cubic centimeters. The volume is pi r squared h. I know that for a cylinder. So here's an equation relating the two variables. It came from that volume statement. Okay, so now which variable should I solve for? I can solve for either one, but it's worthwhile thinking what's going to be easier. If I solve for the r, I'm going to have to take a square root. So let's not do that. Let's solve for the h. And then I get 1,000 over pi r squared. All right, and then for step 3, I'm going to sub this into here. So my area is equal to 2 pi r times 1,000 over pi r squared. All right, yeah, that sounds right. Plus pi r squared. All right, and that looks horrible, but actually it's nice because the pi's cancel, the r's cancel. So what do you really have here? You have 2,000 over r plus pi r squared. So I need to take the derivative of this, so why don't we write it 2,000 r to the negative 1 plus pi r squared. Now I've got my simplified equation and just two variables. Step 4, I want to take the derivative. A prime is equal to negative 2,000 r to the negative 2 plus 2 pi r. All right, that's my derivative. Now, typically when you go to solve these equal to 0, you're going to get equations that are not easy to solve. Or it's not that this is not easy to solve, it's easy to solve, but it's not obvious how you would solve it. What am I going to do to solve that? So one thing you might consider doing is rewriting your negative exponent back as a fraction, and then asking, could I multiply by the least common multiple of my fractions? Could I multiply both sides by r squared? I can, as long as the r squared is not 0. Well, r is not 0, or I wouldn't have a can. So yes, I can multiply by r squared. And then I get negative 2,000 plus 2 pi r cubed, because I'm multiplying by r squared, equals 0. I put the 2,000 over, divide by 2, pi r cubed equals 1,000. Divide by the pi, r cubed equals 1,000 over pi. It's nice that 1,000 is a perfect cube, so r equals the cube root of 1,000 over pi, which is equal to 10 over cube root pi. All right, now that's your critical point. So you could rationalize the denominator, but it's probably not going to be helpful, so let's not. Okay, next step, we'll finish this problem up.